Hello, everyone. Welcome to another session of ExpoLab Blockchain Speaker Series. Today is my great pleasure to have Dahlia Malkhi from Libra, and now it's called the Diem Association. She is, I would say, the real force behind the whole Facebook Libra blockchain project, and she has had tremendous impact and seminal work in distributed fault-tolerant system, from flexible paxes to more recently hot stuff. So it's just a wonderful and a great pleasure to have Dahlia today with us. And she's also been the founder of VMware Research. She has been senior scientist at AT&T, principal researcher at Microsoft, and so just tremendous experience and impact in this field. So without further ado, please take it away.
Thank you, Mo. Pleasure to be here today, virtually. What we're going to do is, this is your last session for the semester. We're all, zoomed out of Zoom presentations. We're going to play a little game. I had 2 minutes to change the title slide from Libra to Diem, but not the rest of the presentation. So you're going to see a lot of Libra. However, you're going to catch me every time I say Libra instead of Diem. And you can whistle, you can shout, or you can just keep tab of it. When you ask questions, every time you say Libra instead of Diem, I'm going to keep tab at it and do you back. Okay, good enough?
Sounds good. And so maybe since you mentioned that, I think it's an important point. So you are our 27th speaker, and so this is the final session of this speaker series. So we definitely saved the best for the last, and we now have a little game to play. So I think it's exciting. We're all looking forward to it.
Cool. The second thing I wanted to say is really feel free to turn this into interactive, session. I prepared a bunch of slides, but I'm not wed to it. So feel free to ask. So with that, in June 2019, Facebook announced to the world their intention to launch a global currency, then named Libra. That doesn't count because I remember to say then. And the formation of an association that will develop the technology and operate the platform over which the Diem payment network will operate. The mission of Diem is to create a simple, inclusive, efficient payment platform that will reach everyone, everywhere. Anybody with a smartphone will be able to handle the currency that is supported by the payment network and financial services. Some, imaginative and creative that we can't even think of today will be able to come to the platform. So that's the compelling mission and the vision. And what Diem, the Diem payment network, the DPM, what it is very simply, it's a blockchain-based system that records the history of payments and keeps track of account balances with the set of stable single currency stable coins and a system of financial services that support the issuance and the handling of stable coins. So with this mouthful, in order to deliver this global disruption, the main thing that Diem needs to do is gain the trust, and it's gain the trust of the users, the consumers, gains the trust of financial world, and gain the trust of regulators. So it's 360 gain trust. And we do it in 3 main columns. We want to gain the trust of everybody in creating an efficient medium of exchange that can be handled in everyday life and in every application. We want to gain the trust of everybody in the foundations. This is the technical as well as the economics foundations on which the system is built. And we want to gain everybody's trust in the ability of the framework and organizations that we've established to continue growing and evolving this platform and maintain a distributed, collective, and inclusive governance that allow to grow these, the platform. And this is, all of this, to bring this down from kind of a fluff or a marketing level down to earth, all of this is very, very different from anything before that. So if you think about the evolution of blockchains and cryptocurrencies and crypto economic systems, it started with the idea of creating a decentralized platform that bypasses any regulatory oversight and any existing mechanisms, and is really controlled and governed and operated in a completely decentralized way. And so if you look at the three kind of layers operating for a crypto economic system, there's the infrastructure layer, who operates it. Then there's who's allowed and who benefits, and the mechanism for creating value or minting or tokenizing value. And then there's the financial services operating on top of it, because at the end of the day, a virtual imaginary world at some point needs to have entry of fiat and exit and merchants accepting it or something in order to hold value. So these are the virtual asset service providers that built on top of it. So if you look at the first generation, mostly Bitcoin that introduced this disruption very soon after Ethereum, the infrastructure, the foundations has been completely public and peer-based. Everybody participates in the operation, everybody has a chance to it, and it's completely decentralized, and it's out of any jurisdiction and any sovereign control. The way value is created is by allowing the participants to create value in the network. And so the primary mechanism for for these networks to operate is as a holder of value, not as a means of exchange, but as creating value and holding value. And some of the difficulties that are associated with them is the liquidity and the volatility of this value. And only on top of that, when interfacing with the real world, financial services had to have any kind of liability and any kind of responsibility for their consumers. So this led to the emergence of the layer 2 services that are operating above these platforms and essentially provide a stable, regulated means of exchange, not a holder of value, through the issuance of stablecoins. So this includes blockchains and systems like USDC, DAI, Paxos, Gemini, and so forth. And what they're doing is they're anchoring a fairly minimal anchor on the unregulated infrastructure, and using it for transparent settlement and issuance of tokens. And everything on top of it is regulated and centralized. So essentially, these systems come as a centralized service provider. They issue a token which they back in a very trusted manner, and one that is heavily audited and regulated, such that every coin that's minted or issued on these blockchains is backed by them, and they operate this issuance mechanisms in a transparent way and with immediate and efficient finality by anchoring themselves on a decentralized infrastructure. And once again, the wallet providers, the service providers that are providing the entry and access to the system, they are completely regulated and centralized and provide the same responsibility and compliance that any other money transmitter should do. I do want to note that even though the very, very foundation is decentralized, really the token issuance itself is completely centralized, because somebody has to, at the end of the day, say, if, for example, Ethereum forks, or if there's a problem, or if there's a compliance issue or sanctions that need to be enforced, this is all done by the entity that controls these tokens. Diem is completely different in that all three layers are ones that are distributed, and in that we are seeking to be licensed from the ground up. The entire infrastructure, the entire layers of the code base, the entire architecture is distributed by design. It is controlled and operated by the Diem Association and its 27 members. And we are seeking a license to operate as a global medium of exchange and as a global payment platform, with the entire system having this distributed control.
So this is really, I think, especially useful for what we've been covering in the course. I wonder if you can maybe just say a few words on that issuance of this token. Is it something backed by something, and how does the issuance works? How does the value of the token is determined, and any sort of a life cycle on the actual currency? And from an understanding, the Libra is perhaps also creating this global currency.
You just said the L word.
Okay. Yes, the Diem is creating the global currency, in addition to be, I guess, in this distributed global payment platform as well too. Yeah, so I have some slides later on the technical side of it. I actually removed from this talk some of the more macroeconomics aspects. So let me just speak to it. On Diem, what we're going to have is the mechanism for issuing single currency stablecoins. So, for example, there could be a Diem EU or a Diem British pound, or a Diem yen, and of course, a Diem US dollar. Each one of these will be issued only by the licensed payment company that we are seeking to regulate and to obtain a license for, and that's Diem Networks. The treasury of Diem Networks is the one that is the only one that can create or issue these stable coins on chain. And the guarantee that we provide is that this issuance is backed one for one, mostly in cash reserve, handled by a trusted reserve custodian, which again is regulated and adhere to the highest standards of maintaining this trust, with the guarantee that at any moment in time, there are no more tokens on chain than there are backed by the reserve. And again, this reserve guarantees stability of the investment, no loaning, it's one for one backed, as well as capital management and risk buffer management that adheres to the highest possible standards. So with this is what we're asking a license to operate. What this guarantees is that at the infrastructure level, there's always backing. If anybody wants to redeem their tokens back, they're always backed. Moreover, we're also requiring all of the participants that are directly accessing the platform to also have one-for-one backing for the accounts that they are custodying. Maybe I should move to the next slide and give you a kind of a bird's eye view, somewhat from a technical point of view. But look, I'm not an economist, and this course is mostly technical people. So this is a bird's eye view of the Diem platform and its component. So let me go very quickly through it. At the bottom, at the foundation, we have the Diem blockchain. And what it is simply a mechanism to replicate the history of transactions. Most of the transactions are payment transfers, but obviously there are also governance and maintenance transactions. On top of the blockchain is what we call the Diem framework. This is the set of rules that define the logic of how participants
can interact with the blockchain and ask to change the ledger state. So the framework, you can think of it as the set of software modules that Diem allows, after testing and after scrutinizing them, to be part of the state that the platform stores. And they define the only way in which you can access the state of the blockchain and mutate it. This framework is written in a new language called Move, and I'll say a few words about it later, that was designed especially to provide the safety of financial assets and handling of them. On top of the blockchain and the framework that provides the API and the rules for interacting with it, the participants that you will see when we launch and the personas are essentially, three types. First of all, there's Diem Networks itself. It operates the reserve, and it is the only entity on the blockchain that can create and destroy token resources. It does that through a system called the Association Operation Services, or the AOS, that secures those critical operations of the reserve, as well as securing the governance and compliance operations by Diem Networks. The Treasury interacts directly with networks of designated dealers. These are, you can think of them as banks. They are actually banks, and they are the only ones who can ask the reserve to swap fiat for tokens and effectuate mint and burn operations. So the designated dealers interact directly with the reserve. They transfer, they establish financial relationships with them to guarantee counterparty risk management. They can transfer fiat directly to the reserve, and Diem Networks, in response, will mint tokens on the blockchain and send them to the addresses that these designated dealers establish on the blockchain. This network of designated dealers are the ones that provide liquidity on and off hours with immediate service to all the financial services, the VASPs, the virtual asset server financial services that are operating on the network. And they're split into two types: wallets and liquidity providers. Liquidity providers are, again, ones who can establish participation, obtain tokens from the designated dealers, and they can serve further wallets. The end users, the end consumers, as you can see on the slide, are outside the perimeter of the payment networks. They are participants of participants. They're not directly accessing the network at first. In order to become, to directly access the network, you need to be permitted by Diem Networks as a participant that adheres to compliance and regulatory oversight. Questions on this? I'm gonna, in a few slides, I'm gonna overview very quickly kind of 1, 2, 3, 4, 5, the blockchain, the framework, talk a little bit about minting and burning. And then if I have time, I wanted to switch gears and talk about some of the more academic work.
One quick sort of clarification for the big picture. So one is the one-to-one asset of the user. Is that sits in this dotted area, that one-to-one backing, or is it outside that dotted area?
So the one-to-one backing is guaranteed by the reserve operations, and this is guaranteed contractually as well as technically. The reserve never mints or burns tokens without a corresponding exchange with designated dealers. And the security of this operation and orchestrating these flows is something that a system that custodies addresses secures.
I see. So one last question in terms of this big picture. So kind of to see what is really happening here is that what Diem provides, I said it correctly, what it really provides is, as opposed to have this banking system and perhaps Visa card to connect the different banks, it says, okay, bring the asset, and once you brought the asset, so they have different entry point for different banks to, or for the user of the banks to put the asset into this dotted framework, and from there on, you no longer have to kind of worry about the banking system, sort of virtualized. And so all of the movement of the money and the assets is just now within this framework, backed by the fiat money that different banks bring in. But at the face of it, all those boundaries kind of disappeared, and allows a very fluid movement of the Diem currency.
Yep, and this is really what tokenization is about. It's not a security. It is a proxy for a liability that's represented by a central bank and government. It's not creating value out of nowhere. It's not creating utility. It's a tokenization. What it provides, different from traditional payment system or banking system, is immediate finality, immediate settlement, transparency, and inclusion. So it allows tech and innovation to come to the platform. If you wanna start a startup here in Silicon Valley tomorrow and access SWIFT or access the FedWire system of settlement, good luck.
Thank you so much.
Other questions, comments? All right, let me talk a little bit about the blockchain from the angle of why we think that this is a platform that can gain your trust as consumers, as well as Washington trust or the trust of regulators. And the reason we do this is we chose to operate this platform over a permission set of participants. Each one of the participants is itself a company that goes through, a rigorous selection process for their ability to operate services 24/7 and have the technical strength to operate a transaction recording system. So essentially, each one of the validators that we have in the Diem network could, if needed, operate the entire payment system on itself. It stores the entire history. It has the capacity to execute transactions. It belongs to companies that operate these type of services all the time. However, we're going to have, right now we have 27 members in the association. And so should any one of them experience any cyber attack or any disruption or temporary unavailability or network problem, any one of the other 20 plus nodes can immediately take over. So in some sense, this is a system with zero recovery time, zero failover time, and not with 1 or 2 replicas. But with over 20 replicas. Now, in the blockchain world, decentralized often conflates or is synonymous with millions of users. But the reality is that the permissionless systems out there are not really decentralized. They very quickly devolve, and it's hard to resist to being controlled by a handful of parties. If you look at Ethereum, if you look at Bitcoin, Bitcoin is currently more than 50% of it is controlled by 5 large mining pools. Ethereum, it's probably 3. Stellar, 1. So you start with a very, very decentralized basis, which is it leads to rich getting richer phenomena and consolidation. Here, this cannot happen. The association was established to retain the distributed control and distributed nature of it. Moreover, in our deployment we contractually enforce diversity criteria that guarantee that these validators are deployed in geographically dispersed regions in multiple clouds, such that no single point of failure, whether it's geographic or whether it's administrative, no single point of failure exists in the system, and no entity or no platform controls more than a third of the validators. The deployment itself is publicly accessible, but not directly. So the inner circle of validators is not going to be directly accessible. Each of the validators will operate full nodes that are constantly synchronizing their state with the validators, and they will be the upstream nodes to which public participants and other full nodes are going to connect to. So this is, of course, something that in this course people have worked on a lot. This is a Byzantine fault-tolerant replicate system. But when you ask yourself, what is BFT good for? Then this is what it's good for. It's to gain the trust in its diversity, in its fault tolerance. And the fault tolerance is not only for the unavailability or the benign crashes, but what we see is that the way these systems fail typically is with insider attacks or cyber attacks. In those attacks, when you have a replicated system, the system faithfully replicates contaminated or corrupted state, and this system will not. In addition to it, the fact that this is deployed over a distributed control, a collective run by association nodes, is very important for the governance and the growth and the ability of this system to evolve in the future without being controlled by any entity that is, driven by economical interests to become proprietary.
So kind of also understand the picture is that these mid-tier validator, they're essentially an observer. They don't really engage in the consensus itself. The consensus is only done within the inner circle?
Correct.
Cool.
All right, let's move on. So I talked about how important it is to let the system evolve. Now, the Diem blockchain is a system that governs itself. So when the Genesis block is deployed, it contains a set of initial permissioned set of validators, but it also contains the rules that allow to change every aspect of the blockchain. So you can change the set of validators, you can remove validators, you can add validators, you can change parameters on the network itself, like account balances or compliance measures or other things. You could change, obviously, the software modules that define the rules for interacting with the network. You can even come and change the state of the system when you need to patch it. Now, when you think about it, if you think about the DAO attack of 2014 on Ethereum, the community had to go and effectuate a hard fork in order to change and revert a really, really bad occurrence in the network. And first of all, it did effectuate a fork. And, as you know, some part of the community is still following, the original Ethereum network that didn't change. So it devaluated the coin, and that happened to Bitcoin as well, multiple times. Here, there's the ability to evolve and decide by the association when a bad event happens and you need to fix it, or when the software needs to update. And so we believe that financial systems evolve and change dynamically very quickly, much quicker than a community of millions of users can come to a consensus and evolve. And so the mechanism for evolving and updating and changing the Diem blockchain is through a reconfiguration operations. And these appear transparently on the blockchain itself and mark the time and the place where changes happen to any part of the software. And again, it could be the validator set, it could be the software itself, it could be any parameters. Now, these reconfiguration transactions are, of course, super sensitive. You have to secure them, and you need to define the governance mechanisms for who can send these transactions. And here the Diem Association established the two paths for governments: the happy path, or the business as usual path, and then there's the urgent security or compliance need path. So when the protocol evolves as usual, business as usual, and you simply want to continue evolving the protocol, the Diem blockchain is governed as an open source project with a team of maintainers that have maintainer rights on the open source project, and with a steering committee, the technical steering committee, that has oversight over them. There's a mechanism for proposing changes to the protocol. That's the DIP, Diem Improvement Proposals framework, by which the community can make proposals, and when they're accepted and implemented and merged into master, at the next release, they're effectuated to the blockchain. In order to actually roll out a change after it's been implemented and discussed and so forth, 2/3 of the validators need to attest that they've installed a new version of the software successfully. It looks like what they would have expected, and follows the discussions that they saw on GitHub and so forth, and protect this kind of rollout. And once they give their signed attestations, that turned into a transaction which is properly signed and effectuates this reconfiguration. On the right-hand side, there is a change protocol or change management process for urgent fixes. So when there's compliance or risk to the payment network itself, the company, Diem Networks, the licensed company, does have the means to go and fix a bad transaction, a security breach, or any kind of urgent operation.
So just a quick question here is, in terms of this governance, so the example actually you provide with Ethereum and Bitcoin, in those cases, perhaps a single person decides what's going to happen, whether to fork or not to fork. I mean, there's no really distributed governance at that point either. But in here, the setup is such that those inner validator are those that I guess the 27 entity or the whatever number of validator inner nodes, are those reach a consensus on to make these changes, or this is done by that, I forgot what you call it, the custodian?
It's a really good question. Let's distinguish between who has the decision authority and who has the credentials or the execution power to execute the decisions. So the 27 validators are not deciding at the time of the rollout, whether a new algorithm is better than a previous one or things like that. This is something that the community discusses, and the association, through its oversight body of the technical steering committee and group of maintainers, governs, just like an open source project does. What the validators are attesting to is the safety and the security of a patch. And this is, again, a place where BFT consensus, if you ask why blockchain, this is where it helps. A single rogue admin or just negligent admin or a system that has been breached will not allow anybody to roll out a bad version of the software. And again, if you look at some of the stuff that's going on in Ethereum right now and some of the other networks, people don't even know what the right variant of the software is. Here, remember, these attestations is not really exerting any judgment. They're really securing. And in terms of judgment, the reason we have the business as usual versus urgent path is, remember, there's no question when, like when Ethereum forks, there's a question of which fork the users believe has value, because it's a holder of value. Here, there's no question where the value is. The value is in the Diem network's treasury. And they are the ones that consumers and customers at the end of the day has claims to. So Diem network is the one that decides where the network is and what to do with it.
So would it be fair to say that there's that governance body that they have centralized way of creating the law or writing the law, and these validators, a decentralized safe executions of those mandates and regulation by that governing body?
The second part I agree with fully. The first part, it's not centralized. It is a consortium based. It is.
Yeah, the consortium. Yes, exactly. Sorry, a consortium that the 27 members, whatever they come up with as a body. Okay.
And this is really important. This is, to me, a key value of why blockchain and why Byzantine fault tolerance. All right, let me skip some slides. Let me move to minting and burning, since there were questions here. So the process of minting and burning from a technical point of view is designed to guarantee that, if the power goes off at any moment in time in this protocol, the invariant that you maintain is that you always have backing in fiat of the coins on chain. And so this is in the financial world what is often referred to as DVP, delivery versus payment guarantee. And so the protocol is designed such that designated dealers are allowed to request a mint order. They will receive a pre-mint authorization from the Association Operations Service, this orchestrator of flows. This pre-mint order is something that guarantees that the operations will succeed once the fiat is transferred, and there's no risk. The designated dealer will then send the money transfer. The AOS automatically monitors for the transfer confirmation. It immediately issues a mint operation on chain and sends the money to the designated dealers. The burn operation is the inverse of that. When a designated dealer wants to redeem coins, it sends a redeem order to the AOS. The AOS will again confirm that there's enough fiat liquid right now to the designated dealer. The designated dealer will then move the coins first to a pre-burn account on chain that only the reserve can then access. Okay, so again, this preserves our invariant that already the coins are burned, or at least they're in an area where they're not really usable for the payment system. Then the fiat transfer will happen. Once it's confirmed, the Treasury authority will go on chain and will move these coins from the pre-burn account and destroy them. If for any reason the fiat transfer fails, then the Treasury can take the coins from the pre-burn account and return them to the designated dealer. Let's see. I wanted to switch gears for the remaining half an hour or so, and talk a little bit about the depth of the tech behind the design of the Diem system. So in order to create a trusted, secure, and safe core for the Diem blockchain, the community went through 40 years of advances that led to creating a BFT protocol that can really scale to internet scale, have essentially a linear complexity in its behavior, and will be safe against any communication disruptions. So what this table kind of shows is a slightly skewed historical overview of the evolution of BFT protocols from their introduction in '82 by Lamport, Peace, and Shostak. I don't know, is there anybody on this Zoom call that doesn't know the basic, Byzantine generals story and protocol and its property. I guess you can use the raise hands motion of Zoom. So I assume this audience does not need an introduction to that.
Well, I think if there's a story, I mean, the story not everybody may be aware. I mean, everybody I think knows about PBFD, Ziziva, but the story of maybe that would be interesting to share.
Yeah, it's my favorite story in the whole world. So this is a quintessential story of a technology that's developed, with the vision and a core that finds a completely different use 40 years later, and really shows the gist of research. So in '82, actually a little earlier, in the late '70s, NASA approached a group of scientists here in the Silicon Valley in SRI, Stanford Research International, with a design for a fault-tolerant control system to operate the control system of a spacecraft cockpit. And the design had three systems with sensors and with a network connecting them, a real-time network connecting them. And, NASA figured that, some of them might get faulty and some sensor may have a faulty reading. And so they designed a system with voting. 2 out of 3 need to vote with the same sensor reading, in order for the control system to effectuate some action. And it came with this design to the group of scientists and asked them to confirm formally that this design is correct and is safe. And so what happens, and these 3 scientists were Lampert, Pease, and Shostak at SRI. And so what happens is, the story is they looked at the design, and first of all, they found that it was flawed. Secondly, they proved that in the settings of that system, which did not have public cryptography, it had real-time communication, but no signatures. In that setting, you could never have any design that would be safe if sensors could arbitrarily have arbitrary readings with only 3 systems. And they proved the lower bound, and they said, proved that at least 4 would be needed. And for good measure, they also gave the first algorithm that was synchronous and was safe against a third, less than a third of the participants being faulty. A good result needed a good story, and so they invented this story of Byzantine generals trying to coordinate their attack, and some of them could be traitors, and hence the community got the name Byzantine failures, which is what we use to model arbitrary bugs as well as malicious attacks to this day. What I find truly amazing about this story is that they extracted the minimal problem that you need to address in order to solve the system, the control system back there. And they said, if 3 control systems can agree on a single bit, then they can agree on anything. You can operate it again and again and again. And so they formulated this consensus, Byzantine fault-tolerant consensus problem that really remains the core problem model for coordination and replication in systems. However, the solution they introduced was, first of all, synchronous, and secondly, was not meant to scale. So in terms of the number of operations and messages that it sent, it was super polynomial in the number of participants. Dwork, Lynch, and Stockmeyer in '88 introduced the first solution that would be safe even if the network was not synchronous, and thereby allowing it to operate on, internet or even data center networks that are not like the real-time network of a control system. And then 10 years later, the community, through Castro and Liskov, introduced a practical version of it. And by practical, what they meant is that in all steady state scenarios, only a quadratic number of messages are exchanged. However, when there are failures, and in particular when the leader of PBFT fails, the protocol they've introduced was essentially based in principles on the Dwork-Lynch-Strokemeyer protocol, and it resulted in n to the 3, in cubic communication complexity. And so since then, the community has really looked for 2 decades for a solution that would be linear. And what I would add to it is not just linear, but also simple. So all of these solutions were made for experts, and only experts could really implement and deal with them. And then what happened was blockchains. Bitcoin, Nakamoto consensus came up with a completely different mechanism that looked much more simple. And from the blockchain and cryptocurrency world, introduced mechanisms that had very different flavor. So if you look at Nakamoto consensus, it looked like a very, very natural protocol for mining networks. Whenever somebody mines a new result, they add a block to the network. And in order to chain them, you need to prove that you've invested the right amount of work. And that was pretty difficult. And that created, for the most part, the ability to chain blocks using this proof of work into a chain that everybody agrees to. And so what we did a few years ago is introduce a protocol that kind of takes the flavor of a Nakamoto consensus protocol and brings it to the standard setting of Lamport-Piz-Shostak and all of these protocols, and works for a known set of participants. And this is the hot stuff protocol. And similar to Nakamoto consensus, it works by chaining blocks to each other through a mechanism that guarantees that the chaining is for the most part unique and requires 2/3 plus 1 of the votes in order to chain them. Sometimes you get, forks in this chain, and the same link, the same diamond shape here is used to create 2 forks. However, in order to guarantee uniqueness, it's enough to wait for a consecutive chain of 3 of these blocks and 3 of these certificates of 2f plus 1 votes in order to guarantee that no 2 forks can get this. And what this protocol provided is very nice academic measures. It's linear in most paths, and it's safe against asynchrony. But more importantly, it provided the developer friendliness and the simplicity that brings confidence that implementations are simple enough to be robust. And if you look at these 2 protocols, they look very similar. And so this has become the core of the Diem blockchain, as well as others. I'll pause for questions here. All right. So I think I have time to talk about 2 more innovative mechanisms that we've injected into the development of the Diem blockchain core until now. So one of them relates very, very closely to this protocol, the 3-chain commit protocol of hot stuff, and its productionized version, which we call Libra BFT. That's the name. It's not going to change when with the Diem change. So the first mechanism I want to mention is a optimistically higher resilience BFT protocol, which is superimposed on the hot stuff mechanism. And the idea and the observation is that when you have these chains, if each one of them obtains exactly the same 2f plus 1 votes, then we're really resilient to only 1/3 of the failures. However, if there's variance in, these set of 2f+1 votes in these QCs, what we want, and this is what happens in practice, right? As the proposals of these blocks are rotated and they collect votes from different sets of responders, what we're seeing is that gradually over time, different sets of validators will respond. So for example, if we have a network of 4 participants, A, B, C, and D, then maybe this block was proposed by A, and the votes on it are by A, B, and D. And then maybe this block was proposed by B, and because of network delays, A, B, and D were the ones that certified this block, and so forth and so on. This was A, C, D. However, normally we cannot really use the fact that you get more and more of these votes. And moreover, especially in a setting like the Diem setting, where these validators, as I said, are very robust and highly resilient and reliable participants that are contractually required to participate and respond and vote, you expect to get votes from everybody and not to have failures. But we're not really able to use these votes because each set of votes is voting on a different block, and you cannot mix and match. So the commit rule that says that you can commit the head of a block when you see a chain that has 3 quorum certificates, you cannot unify all of the votes on these quorum certificates and say that this head is now attested to by a larger set. You cannot mix and match. However, what you can do is you can do it with a very simple modification. If each one of the votes will actually say not just that it's voting for the preceding block, but will also be what we call a strong vote. It will also say that it hasn't voted for anything conflicting up to some place in the branch. So in this picture, these votes are essentially saying, I didn't vote for anything conflicting ever since this head of the chain. And so do these votes, and so do these votes. Now, what we can actually do is we can combine all of these votes and say, well, now we actually have votes from A, B, C, and D certifying all of this chain. And this means that the head of this chain is committed with stronger resilience. So this head is resilient even if up to 2/3 are faulty, not a third, because they've already participated. Okay. So essentially, this is sort of a new way to think about Byzantine fault tolerance, where if the adversary is active and is trying to attack the system, it sends votes, and we can start seeing more and more votes. We see active participation. We actually get higher resilience to real corruption attacks. If the adversary is not actively attacking, they're just benign crash failures, it may not send these votes, but then it's also not active. It's not trying to corrupt or fork the network. So what we get is we get optimistically higher resilience than what the lower bounds and the foundations, the academic foundations, allow us. And we're not breaking these lower bounds, but we are bypassing them by realizing what type of attacks or failures actually happen on the network. If I'm looking for normal finalization, no delay. If I'm looking for stronger, for this green finalization, will it take much, much longer? So our experiments show that, normally to get 20% more resilience, 30% more resilience, not up to 2/3, it's linear, but it happens very, very quickly. So in a network of 100 nodes, you might increase the commit finality from 5 seconds to almost double to 10 seconds, but not much more. Normally, this diversity in votes occurs without trying too much. We can also help it. So we can also say, hey, look, here, for example, we have two quorum certificates that are not contributing too much to the diversity. It's just the same voters over and over. Can we wait a little longer? Can we delay on this quorum certificate and wait until a new voter will arrive? And again, in the normal situations, there are no forks. Everybody will immediately tell you, yeah, we're certifying everything. And then you get the diversity without delay at all. So we actually played with this a little bit and showed that either you wait for the stronger resilience, or you wait normally in the normal mode and delay even the normal finalization, but then the stronger resilience occurs much faster.
Makes sense.
All right, I want to talk about one more topic, which is some novel approaches that we've injected to testing our systems and dealing with these adversarial, Byzantine attacks. And so this project, which we call Twins, deals with the problem and the challenge of systematically emulating and observing Byzantine attacks. So Byzantine attacks are pretty challenging for a system developer to protect against for a lot of reasons. First of all, they're unconstrained. So there's no systematic way to enumerate essentially, infinite behaviors. Secondly, even if you could enumerate them, the state space explodes very quickly because they can do whatever they want. And a lot of the ways in which a Byzantine node can behave is not very interesting. If they send a message that doesn't have the right format or doesn't have a signature, that can be easily filtered at the network level. The last challenge that we have with Byzantine fault-tolerant system development is that even if you had a very good way to implement some attacks, some Byzantine attacks, it's not clear that you want to maintain attacking code in your code base that you put out on GitHub and publish to the world. So for all of these reasons, BFT development is challenging, and finding bugs and finding attacks is really challenging. So what we do with the Twins approach is to observe that the most interesting attacks are actually internal. So they leverage the correct behavior and code and modify it in a subtle way such that they go unobserved, and everybody, all the other nodes will treat the behavior of a faulty node as if it's correct. And with this observation, the way the Twins attacks work is they deploy for a faulty node, they deploy two instances. They deploy a node and its twin. They give both nodes the same credentials, the same network addresses, the same secret signing keys, and so forth. And so each of them can send messages that look like the same node. However, their internal state is completely different. To the rest of the network, they look like a single network endpoint that behaves badly. So how badly can it behave? So for example, one twin can send a proposal, and its twin will send a different proposal. And we do that, again, without modifying the code, just by playing with the configuration, with the deployment. And in this case, in this way, we've systematically, automatically created an equivocating behavior. The same node is sending two different messages to two different participants. We could have a one node vote for a proposal, and then forget that it voted and violate its own rules by having the twin vote for a different message, because the twin doesn't know about the vote. We could also violate other kind of internal logic where you vote for something, you need to maintain a lock and reject some other proposal, but then the twin doesn't know about the lock and forgets about it, and it's as if it violates its own logic rules. So in this way, we can systematically, efficiently create attacks with the existing code base. We don't have to worry about the code base evolving and keeping up with it. It's automatically and systematically generates these attacks. So in order to effectuate these attacks, what you do is create these misconfigurations. And then we have a network emulator that executes scenarios that are generated systematically and automatically, and operate and execute the original protocol with the misconfiguration. The emulator works round by round, and for each round, it says which nodes will send and receive messages from each others. So you start by saying, what is your faulty configuration? So here, again, I used the configuration with 4 nodes, but I've deployed 2 twins. And what this test is essentially validates the approach itself. It tests attacks when the number of faulties is more than a third. So here you have 2 faulty nodes. Each one of them has twins. And it's very easy to validate that any BFT protocol that you use with this system will lead to inconsistency when attacked by more than a third of the network. So in one round, we will have, let's say, C as the leader, and then its twin will be a leader that talks to, one partition of the network. In the second round, you continue deploying this, and within 3 rounds, if it's hot stuff, you will get conflicting commits because the number of faulties exceeds the threshold of the protocol. So in this way, we've implemented, in just a few rounds and a few steps, a Byzantine attack by more than a third of the network. A more subtle attack would be, as I said, one that affects the internal logic of the protocol. So again, you will misconfigure, but here we don't have more than a third that are faulty, only 1 twin. However, it's enough for this node and its twin to violate the logic of the protocol by going through one round where D gets a proposal from a leader, here A, but in the next round, the twin will actually be communicating with the partition that previously communicating, but the twin will violate any rules, any voting rules that the algorithm has. So in this way, we can generate systematically small scenarios with a handful of nodes, let's say 7 nodes or 10 nodes or 4 nodes, and a handful of rounds, let's say up to 12 rounds, and just go through these combinations of communication and systematically generate these attacks. Let me fast forward to here. So using this approach, we were able to generate scenarios that, first of all, find bugs in some newly published manuscripts. Secondly, we materialized some known vulnerabilities that were already known in the literature. So you go and implement that algorithm and you let twins generate the scenarios. It will generate the scenarios that break these protocols. And we also deployed it on the Diem system itself. Luckily, it didn't actually find vulnerabilities in Libra BFT and the Diem blockchain. However, to validate the approach itself, when we intentionally inject flaws and bugs in the protocol, then Twins surfaces them. Yeah, so I'm personally pretty excited about Twins being a fairly innovative and exciting way to effectuate Byzantine attacks on protocols. And if anybody's interested in this course or in general, there are a lot of directions to continue the Twins work that we're very happy to collaborate on.
So is there other possibility to further expand this set of test cases and perhaps prioritize and rank? I mean, especially when we're dealing with millions of test cases, to find out the best one to run or the most.
There's a lot. There's a lot to be done. So this is really just the first step. First of all, anecdotally, Yes, it covers some limited number of cases. The state space obviously grows exponentially, but intuitively we feel that that is not where the problem is, because when protocols break, they typically break in up to 10 steps. You don't need more than that. But we don't actually know which type of behaviors. We don't know rigorously how to characterize which type of behaviors can be emulated and which types cannot. Also, we've used it so far to test safety, but there are many other properties of BFT protocols that once you have a scenario generator, you might be interested in, like liveness, like fairness, like any kind of specific bounds, timing bounds that you may want to check that hold, performance of the protocol. So that's another direction to extend. Real-time or synchronous protocols is yet another extension that we're very interested in exploring. How to capture timing behaviors, as well as what to observe in them. And also applying twins to many other systems and protocols and see what it results in.
So, I mean, just also kind of our own experience with our own fabric resilient DB, we have about a dozen protocol implemented, including hot stuff, and testing it has been one of the most difficult tasks. And I think be able to do this in a much more systematic way. I mean, we can never test manually at these scales, and especially I think with liveness and the view change. I think that's where our experience shows there's a lot of corner cases. So I think that would be really interesting to be able to apply that. And sort of,
I think if I go back to this slide, so look, the network scheduler is the only system-specific component, and one that you need to tailor to the system. So you have to control the delivery of messages and decide things like who is the leader in a round, or at least you have to know who the leader is, even if you cannot decide, and which group of nodes or validators are communicating with each other. The scenario generator itself is a Python generator. Everything is open source and released, so that's available. And the integration with existing systems, so long as you have a component that emulates a network, it can be integrated with. And we have a team of researchers that are happy to interact over it.
So in that figure that you were showing, are there sort of any thoughts on making probabilistic things? So the scheduler probabilistically, maybe concurrently start creating these twins boxes and flowing messages?
Yeah, we thought about it, and we played a little bit with probabilistic scenarios to increase the system size and the number of scenarios, the number of steps that we can effectuate. But the problem is that it's very easy to miss those critical attacks when you're probabilistically sampling. However, generally pruning the space in a smart way, applying any kind of probabilistic testing techniques. I don't know. I feel like there's a million directions in which this could go. I think that the key observation here is that really the material way in which Byzantine attacks happen can be captured by twin behavior. Actually turning this into a completely effective system, the integration, the effectuation of scenarios, I feel like there are a lot of directions in which it can grow.
Sounds very fascinating. Just one last question, just out of curiosity. If the underlying system that is built is aware of this twin behavior, is there any way that they could function in order to circumvent being caught?
Sorry, not sure I understood the question.
So underlying system, if it's so the implementation, we don't have control over the implementation, and they know they have a prior knowledge of how this twin behavior testing is happening. Is there any possibility that they can use that a prior knowledge to hide anything, behave in a certain ways, to ensure that you can pass all your twin stuff. You can
so if I'm an attacker and I know that you've tested the system with twins, can I still subvert everything that you're protecting against? Look, Byzantine attacks are so hard to implement to begin with that if you actually know that the system is hardened, I mean, it's always there's no foolproof system. It's always an arms race. It raises the bar. Does it guarantee that the system is foolproof and no attack is possible? No, I wouldn't say that.
So I just want to take really this opportunity on behalf of UC Davis and ExpoLab to really thank you for this lecture, which was also marked as our CS Department Distinguished Lecture Series as well too. So I really want to take this opportunity and really thanking you for this amazing lecture.
Thanks for having me, and I hope you have a nice break, everyone.